Hi, I'm Steve Gibbs. I'm going to be your host today as we look at quadratic equations, moving further through the Using Algebra in Engineering section of this MOOC. I teach electrical engineering at the University of Texas at Arlington, and I'm looking forward to this session. Today, our topic is quadratic equations, and we're going to look at a quadratic equation with the initial example of a soccer goal. As you see, the ball is kicked, goes high through the air, arcs down into the goal, and follows a path that we call a parabola. A parabola is the name we give to the graph created by a quadratic equation. Okay, now watch the path of the ball as it's kicked. Starts at the ground, makes an arc, you see it peak, and then drops in, hits the ground as it goes into the goal again. This is our parabola, which is a quadratic equation. We'll come back to it. We'll analyze this particular kick and come up with the mathematics behind it. But the whole idea is that if a soccer player can do it just looking at the ball, then let's figure out how we can do it looking at the numbers. We've just looked at a soccer ball being kicked into a goal following a parabola. Mathematically, that's what defines a quadratic equation. So we're going to be looking at parabolas, but looking at the math behind them. So the question becomes, what is a quadratic equation? Well, let's start with a couple examples. You notice that they both have great similarity. They'll have three terms: a second order term, first order term, and a constant. So let's look at it. It's a second order polynomial, and it's in one variable. So we've got the second order polynomial, and then we have the single variable, in this case, the letter x. We'll look at three different techniques to solve quadratic equations. The first technique we're going to use is the quadratic formula. Well, you're going to say, why choose that one first? And the answer is because it always works. Factoring is a whole lot more difficult, maybe a whole lot more difficult, but factoring is the second technique we'll look at. The third technique we'll look at is called completing the square. Okay, let's take our first run at solving a quadratic equation by using the quadratic formula. The particular expression we're going to use is minus 5x squared plus 10x plus 15. As we look to apply the formula, we'll use the formula minus b plus or minus b, the square root of b squared minus 4ac, all divided by 2a. Now we got to figure out what term goes where. The a term is the first term, so that's minus 5. That makes it fairly obvious that the b term is going to be the plus 10, and that the c term is going to be a plus 15. So for the b squared, we're going to have 10 squared. For the minus 4ac, we're going to have minus 4 times minus 5 times 15, and the whole thing over 2 times minus 5. So that's what the equation is going to set up to. But as we take this a step farther, let's go back a moment and look at it from a slightly different perspective. What does 5x squared or minus 5x squared plus 10x plus 15 tell us? At x equal to 0, our starting point is going to be at plus 15 units, whatever that is, meters, centimeters, inches, whatever we're using, that's our initial position. 10x tells us the initial velocity, so that at time equal to 0, we have no velocity. As soon as time starts moving forward, that's going to take on a value 10 times whatever the time is, or whatever we're measuring. The third term, the squared term, this tells us what's called the acceleration. How fast am I changing speed? If we use this in the perspective of gravity, the minus 5x squared tells us that we're going to be going down at the rate of minus 5, accelerating by minus 5 units every second squared. The 10 is going to tell us that we have an initial up velocity of 10 units per second, And we're starting, according to this, at a point 15 meters above the ground level. So those are the three pieces of the term. We'll come back to that later as we solve the soccer ball equation. So for now we have the equation minus 10 plus or minus the square root of 10 squared minus 4 times a minus 5 times c, 15, all divided by 2 times a, or minus 5. Let's start by solving the equation we just set up. But in this case, we're going to start with the plus term first and come back and do with the minus term second. So we crunch the numbers. You can get out a calculator and crunch them as well as I can, and you're going to find out that the answer to this first equation is a minus 1. So the first root that we found for our problem, for our first equation, is a minus 1. Now we use the negative and do a minus 10 minus the square root of 10 squared minus 4 times minus 5 times 15 divided by 2 times minus 5. And we find out here that the value is 3. Again, I'll let you use your calculator or your number crunching capabilities. So what we'll say is the roots of our equation are minus 1 and 3. So let's verify that. When x is minus 1, we take our equation minus 5x squared plus 10x plus 15, substitute a minus 1 in for x, and we have minus 5 times minus 1 squared plus 10 times minus 1 plus 15, and we find out that minus 5 minus 10 plus 15 is equal to 0, just like we were expecting. Let's do the same thing when x is equal to 3. 5 times 3 squared plus 10 times 3 plus 15, again, works out to 0. The second technique, moving on from the quadratic formula, is to do factoring. So if we start with an example, f of x equals x squared minus 6x plus 8. Slightly different example this time. What we're going to be looking for are two numbers that when multiplied together add up to 8, but when added together add up to 6. So the question we ask is, what do we come up with that when we set that equal to 0, we can find those numbers? Two times 4 is 8. 2 plus 4 is 6. So this could work for us. So we set up with x minus 2, x minus 4, and we come up with that as x squared minus 6x plus 8. Minus 2 minus 4, product is 8. Minus 2 plus minus 4 gives us a minus 6. So that we can see from this that our roots are going to be 2 and 4. The last technique we'll look at is solving the quadratic equation by completing the square. We'll start with the same example again, modified slightly, so we'll move that plus 8 over to the other side of the equation as minus 8. Only now as we solve it, we're going to look for two terms. We're going to take this center term, divide it by 2, and then square it as our third term. But to keep the equation balanced, we need to add the same term to each side. Now notice that was to take the middle term, divide it by 2, and then square that quantity so that when we are finished, we get x squared minus 6x plus 9 is equal to minus 8 plus 9. Since minus 6 divided by 2 is minus 3 squared, there's our 9 term. Now from this, we can see that x squared minus 3, x minus 3 times x minus 3 will give us this x squared minus 6x plus 9. We also have the other side of the equation, minus 8 plus 9, is equal to 1. So what are we going to do with that? Let's square the right side of the equation, so we have x minus 3, the quantity squared, is equal to 1, the quantity squared. That means that when we take the square root of both sides, we've got x minus 3 is equal to plus or minus 1. Well, that solves very quickly in that x equal to 3 plus or minus 1 tells us that x again is equal to 2 or 4, which verifies what we looked at with the previous solution technique. Okay, so let's wrap this first part up. In this section, we have looked at 3 different techniques to solve a quadratic equation. The first one we looked at was the quadratic formula, where we used a specific formula, minus b plus or minus the square root of b squared minus 4ac, the whole thing over 2a, as a guaranteed route to solving the equation, to finding its roots. This one requires some math, but it works every time. The second one we looked at was factoring, to see if looking at the equation and breaking it into its parts, we can find the roots of the equation, so that we have x minus the first term times x minus the second term, that together gives us the function that we are trying to find the roots of. The third approach we used was completing the square, where we add the same amount to each side so that we're able to reduce one side to x minus some factor and have that equal to a constant, and together with those terms we can find the roots by solving the associated math. Next, we'll look at the graph of a quadratic equation and look at some terms related to it.